Today's subject is also about quantum mechanics. In my last video, we learned about light's duality. Light is the electromagnetic wave and also have particle property. As a wave, it has three properties: interference, diffraction, refraction. And refraction is that light proceed one interface and with other interface it have propagation like curve and other properties shown in Young's dual slit experiment. It is that the light proceed as a wave. It is called diffraction, and as the light is wave, so their sinusoidal phase meet each other, and so their sinusoidal wave is changing. So at final freezing, the line looks discrete line. It is called interference. And as a particle, we can understand by seeing the photoelectric effect and Compton effect. The result, light's momentum p is described h over lambda and h bar k. It is the formula as a wave, and p equal mass product velocity. It is the formula as a particle. So today's first subject is Schrödinger equation. I'm gonna describe the sinusoidal formula as a wave. So this is wave function about sinusoidal formula, and this is the Schrödinger equation system, and we put the voltage, potential energy, and we can get energy and wave function in output place, and system's formula is like this. So input voltage, output energy and wave function, and the other is called Hamiltonian operator. It is eigenvalue. So this formula is the time independent Schrödinger equation. And next, arrange the concept. When we know the potential energy value, we can get energy and wave function. So we can plot this graph. The black line is potential energy and blue line is energy level, and red line is wave function with number in their energy level. And we can also know the probability of finding electron by square of wave function. So applying this graph, you make the tool name is the infinite potential well. The difference is that the real world vacuum energy level value is 0 top line, but in this tool the ground is 0 and well value is positive infinite, and in this between area there is electron and its width is a. And wave function, to calculate this tool we can get the wave function like this, and we can also get the energy each level, and we should concentrate on this symbol 1 per a square. It shows that the width a is bigger, energy is shorter, like this, and width is shorter, energy is bigger. So in the quantum mechanics system we can show the distance of each energy level is longer, so we can see as discrete energy. But in our real world system it is so microscopic view, so we can see everything as continuous energy. And next is quantum tunneling. In real world, with no engine car is on the top of a mountain, and when it slips because of their own potential energy, so they get that change as a kinetic energy, so it can go to this point, but it cannot go over this height line, so it can't go the B mountain of top. But in the quantum mechanics, wave can go over the potential well. It's just the propagation in the potential well, and wave can go transmission, and the barrier's thickness is also A. The transmission formula is like this, and it is also important about the thickness, because thickness is bigger, the transmission value is smaller as exponential like this. So the real world in the case of matter have their own wave factor and meet the vacuum space because of their potential well and their thickness is like infinity. So the wave function cannot transmission, but if we put the second matter closely, the potential well is smaller. Potential well's thickness is smaller, so the wave function can transmission just some propagation. So applying the real system, when there are some material and this is the material surface, we come closely the matter with tips and there will be the transmission each values. So calculate this value, we can express the as a current. So using this graph we can know the material, how the surface is like and how the is materials periodic, and also can find the cracks like this because with the cracks the current at the cracks place is difference current, so we can find it. It is called scanning tunneling microscope. Its end.